we should also be familiar with the different types of encryption mechanisms that are utilized on those access points. Okay, most people associate that sort of thing with a, like a home network or something like that. But then there's also things that are utilized in an enterprise network that are very important as well. So the three encryption mechanisms that you should be familiar with as far as Wi-Fi is concerned, and for the exam specifically, is the first one's known as wired equivalent privacy, which was, one of the first encryption mechanisms that was deployed on Wi-Fi access points. As we're going to find out, it's one of the first ones that used a stream cipher in order to be able to create encrypted characters as the data stream is being sent. Okay. There were some security concerns and some significant flaws with the way in which WEP was created. So as a result of that, they moved on to a new encryption mechanism called WPA, or Wi-Fi Protected Access, and then a follow-on to that, Wi-Fi Protected Access 2. And we're going to talk about the differences between the two and the types of encryption mechanisms that were deployed for each one of those, which you'll need to know for the exam. Okay, as far as being able to deploy cryptography in small hardware, most people may start to be familiar. Anybody not familiar with like Internet of Things or like small systems that can have kind of big functionality? In order to deploy encryption, you need to kind of have a compact equation to be able to calculate and then provide that as a capability, right? And elliptical curve cryptography is one of those mechanisms to be able to do that. Actually, a lot of people are doing research these days talking about some of the inherent flaws, or what I would say vulnerabilities with elliptical curve cryptography in terms of quantum computing and some of the issues that are relative to that. So there are some issues with it, but from what we're talking about in preparation for the exam, there are some things that can be applied to these systems in order to provide encryption. So let me ask you this. What does that picture look like at the bottom there? Looks like the OSI model, yeah. And so just as we have the OSI model for the methodology of communication via Ethernet, we also have the same type of model that is focused on wireless type of communications, okay? And this is what we call the wireless application protocol, right? And what's nice about this is, just like the OSI model, it follows along in a relatively similar manner. The only difference being is that since we don't have like real wires to connect in, our access levels are just a little bit different, because the network layer is really like the physical layer combined, right? It's all kind of combined because of the fact that's how it communicates. So just be aware that the wireless application protocol is there and that there are different layers for wireless types of technology. Okay, so let's talk real quick about the goods, bads, and indifference of the different encryption mechanisms within Wi-Fi. So we already talked about WEP. It was really supposed to model the very same types of encryption techniques that we would use in Ethernet. But what they failed to realize was that the RC4 encryption mechanism also was paired with what's called an initialization vector. So essentially the seed to start the encryption process. And because that seed was only 24 bits in length, it really had a hard, or it was vulnerable to a brute force attack. And so very quickly, guys that are really good into this figured out that they could just try massive numbers of keys because that initialization vector was so low, and within seconds they could break into it. As a matter of fact, it's a very easy thing to do once you've actually shown and set up a wireless access point in order to run that attack against it. Yeah, it's like 2 seconds now. Yeah, I mean it's not even. So. Mm-hmm. Mm-hmm. Yeah. Yeah. That's a good one to have.